In 1999, NASA launched the Mars Climate Orbiter, a $125 million spacecraft designed to study the atmosphere on Mars. Everything seemed fine with the craft until it actually approached the planet, when it abruptly burned up in the atmosphere. Or so it is believed. In reality, we really have little idea what actually happened to this craft, but we have developed a pretty good understanding of what errors took place back on Earth that led to this mishap. It really boils down to a miscommunication between NASA and its primary contractor, Lockheed Martin, in regards to which system of units were to be used to model force. NASA's navigational team was utilizing metric units, while Lockheed Martin was inputting data under the imperial system. I should mention that under the metric system, force is modeled by newtons, and under the imperial system, pound force. To get a good understanding of the ratio between these two units, 1 pound force equates to roughly 4.4 newtons. So if this information isn't specified beforehand, as it wasn't in this case, disaster is almost always guaranteed. So that brings us to the topic of today's video, unit conversion. So what is unit conversion? Well, in physics, it is the process of changing a quantity expressed in one unit to another unit, while keeping the actual value of the quantity the same. So here I decided to model a certain distance. 1 kilometer equates to 1,000 meters, which equates to 0.6214 miles. And even though these three expressions are represented by three totally different numerical values, they represent the same distance. So how can this be? Well, it boils down to the system of units that is being used, which allows us to better contextualize the numerical value. So let's say this is me. As you can tell, I am not artistically inclined. And let's just say this is the nearest gas station. So for instance, if a friend of mine asks me how far the nearest gas station is, and I respond with 3, without necessarily specifying the units, my response would be pretty ambiguous. Without any context, that 3 can represent really anything. It can represent 3 miles, 3 kilometers, 3 meters. You get the point. So it is always important to specify the units, and being able to convert between these units is equally as important. The system of units most commonly used in physics is dubbed, very conveniently, the International System of Units, which can be denoted as SI, or otherwise known as the metric system. In this video, we'll be covering just 3 of these metrics, which will serve as the introduction to kinematics: distance, mass, and time. So let's start off with distance. As mentioned before, the same distance can be modeled using different numerical values, if and only if the units are properly specified. So for instance, 1 kilometer equates to 1,000 meters, and 1 meter equates to 100 centimeters, and 1 centimeter equates to 10 millimeters. This is information that is especially important when dealing with formulas, given that some formulas are made in respect to certain units. Also, I should mention that in some instances, you may need to convert between the imperial system and the metric system. The imperial system deals in feet, inches, miles, and pounds, while the metric system deals in meters, kilometers, grams, kilograms, seconds, etc. So let's take a look at some of these conversions. 1 inch equates to 0.0254 meters. 1 foot equates to 0.3048 meters. And 1 mile, you'll rarely see any problems on any test or homework assignment that really deal in miles. But this is information that you should just know. 1.609 kilometers. And now let's take a look at mass. 1 kilogram equates to 1,000 grams. And 1 gram equates to 1,000 milligrams. An imperial to metric conversion would be 1 pound equates to 0.4536 kilograms. For time, there are really only 2 unit conversions that will serve much use. 1 minute equates to 60 seconds, and 1 hour equates to 3,600 seconds. This is information that you should come to familiarize yourself with. This is pretty much as easy as it gets in physics, so I would recommend memorizing most of these givens, because a lot of other unit conversions have multiple moving parts, and we'll actually take a look at that in a minute. So let's take a look at a metric that deals with multiple units. Speed/velocity, which for the record are 2 different things, but we'll get into that in a later video. So 1 kilometer per hour equates to 0.2778 meters per second. And 1 meter per second equates to 3.6 kilometers per hour. And for the fun of it, 1 mile per hour equates to 0.447 meters per second. So as you can see here, we have units with respect to other units. Kilometers with respect to hours, meters with respect to seconds, miles with respect to hours. So this is an example of a metric that deals with 2 different units. And to be able to convert will pay dividends in the future. So let's take a look at some practice problems. Let's do 4. And if you could solve these problems with little to no difficulty, you have a pretty good understanding of unit conversion. So let's say you're dealing with a problem that requires you to convert 2,649 millimeters to centimeters. How would you go about this conversion? Go ahead and pause the video if you'd like to attempt this problem on your own. So we know that 1 centimeter equates to 10 millimeters. And with this understanding, we can basically take our original number, 2,649, and divide it by 10 to get our answer in respect to centimeters. And all we'd really need to do is simply move over the decimal place by 1. And this would be our answer in centimeters. Not bad. So let's take a look at another expression. Say you're dealing with mass, 26 grams, and you need to convert this value, I should say, to kilograms. How would you go about this conversion? Go ahead and pause the video if you'd like to attempt this problem on your own. So we know that applying the same logic as this last equation, 1 kilogram equates to 1,000 grams. This is information that we have already gone over. You know what, better yet, we should take the inverse of this. 1 gram equates to 1/1000th of a kilogram. So we're going to take this factor and multiply it by our original number, 26. And that should give us our value in kilograms. You simply just move the decimal place over 3 zeros 3 times. 1, 2, 3. And that is our answer. Pretty straightforward. So say you're given a square. Not a perfect square, but it'll do. And each side length measures at, let's do 2.6 millimeters. Find the area in meters squared. Go ahead and pause the video if you'd like to attempt this question on your own. There are multiple ways of going about solving this problem. But my recommendation would be finding the area of the square in millimeters first, and then going about unit conversion afterwards. Let me do this as quick as I can. Your answer should be 6.76 millimeters squared. And now let's actually shift our focus to unit conversion. So we know that 1 millimeter equates to 1/10 of a centimeter, and 1 centimeter equates to 1/100th of a meter. So to find millimeter in respect to meter, we simply multiply these two fractions. That would make 1 millimeter equal to 1/1000th of a meter. And you may be wondering, how are we supposed to derive meters squared from this expression? It's pretty straightforward. You would square both sides. Simple algebra. That would make 1 millimeter squared equal to 1/1 millionth meter squared. And we have the actual numerical value of the area in millimeters squared. So now we're just looking to find the area in respect to meters squared. So to do that, we just plug this value into the numerator of this fraction. I know it looks like a large fraction, but in decimal form, this is actually a really small number. You would shift the decimal place over left, I should say, by 6 units. 0.0. And this should be your answer. We could actually write this in another way. I might make a video on this, on how to do this later on. I believe this is called scientific notation. Don't quote me on it, I may be wrong. I haven't done it in a while. So perfect. On to the next question. So now for our last problem, let's actually do an imperial to metric conversion. Let's say you have 20 pounds, and you're looking to convert this value to kilograms. What would your answer be? Well, we know that 1 pound equates to 0.4536 kilograms. So we basically take this decimal and multiply it by our original value, which was 20. So it would be 20 times 0.4536. We should get our answer in kilograms. I actually did this equation beforehand, given that it's a decimal. And the answer should be 9.072 kilograms. As mentioned before, there are other units in the International System of Units that we'll be going over in later videos. But if you're curious to know, these are the units that we have not yet covered are used to measure force, energy, And I'll just be writing down some examples of their notation, respectively. Power, pressure, temperature, electricity, and so on. Thank you guys for watching. If you have any questions, comments, concerns, worries, doubts, feel free to leave them down below in the comment section. And if not, feel free to email me at brightpathinsights.stem@gmail.com. I'll actually write that down.